So now we'd like to find the area of the region enclosed by the graph of r equals 2 plus 2 sine theta. And I've sketched the graph here. We're going to use this formula. So 1/2 integral from alpha to beta of f of theta squared d theta. But we need to start by focusing on those limits of integration. So again, I'm going to go back to the advice I gave in a previous video, which is when you're finding limits of integration, start out by setting your expression for r equal to 0. So when we're finding the limits of integration for this problem, set your expression for r equal to 0. So in this case, 0 equals 2 plus 2 sine theta. Okay, so if we move the 2 over and then divide both sides by 2, -1 equals sine of theta. So think about solutions to that equation. So if you think of the unit circle if you need to. So 3 pi over 2 or -pi over 2, this position right here. So call it 3 pi over 2, call it -pi over 2 if you want. It has infinitely many values of theta that correspond to this position here on the unit circle. But I'm going to use I like -pi over 2 for this as a starting value here. So -pi over 2. So imagine a ray starts here at -pi over 2 and starts to revolve, it starts to increase. So it's going to revolve this way. So as it revolves, it's going to think of it like it's sending all these rays out and it's collecting the area. Think of it, I picture it as a little laser beam. It's scanning through here and it's taking a sum. I mean, because it really is taking a Riemann sum in actuality. But so it's adding up the area of this region that it scans through. Again, I mean, I think it's a good idea to take advantage of symmetry of these graphs. So I'd be inclined to use limits of integration -pi over 2 to pi over 2. I could stop scanning when I get here because I know that these graphs are symmetric. So if I just multiply by 2, that'll give me the total area of this region. So I would set this up as the integral from -pi over 2 to pi over 2 to give me the area of this region, and then just multiply by 2 to get total area. So that's the plan I'm going to go with here. But it starts from setting your expression for r equal to 0. That just gives you an angle to work from. And then also use the graph, which I will provide on the final exam. You'll be able to look at the graph and kind of reason what your limits of integration should be based on that. So to get the total area enclosed here, we should do 2 times this integral from -pi over 2 to pi over 2, -pi over 2 to pi over 2, of your f of theta is this function right here. 2 plus 2 sine theta squared, d theta. Okay, so now we got to execute. Oh, and I forgot the 1/2. Whoopsie. It's actually good news then that we're multiplying by 2 to get total area. So now the coefficient is just 1. Okay, so this is 1 times integral from -pi over 2 to pi over 2 of this quantity squared. So if you multiply that out, 2 plus 2 sine theta times itself, 2 plus 2 sine theta. Maybe we should have thought about factoring out the 2, but too late now. This is 4 plus 4 sine theta, 4 sine theta. So 8 sine theta plus 2 sine theta times 2 sine theta. So that'll be 4 sine theta squared, d theta. Okay, so now I'm going to factor out 4. So the common factor across the board there of 4. Now some of this we're ready to integrate directly. So if I factor out 4, I've got 1, which we can integrate right now. If I factor out 4 here, I've got 2 sine theta, which could be integrated directly. And then if I factor out 4 from here, I've got sine squared. So that presents a problem. These even powers of sine and cosine cannot be integrated directly. So with this guy, we're going to need to apply power reduction again. So turn this sine squared theta into 1/2. If we use the power reduction formula right here, this will be 1/2 1 minus cosine of double that angle, 2 theta. Okay, and keep everything else the same. So 4 times integral from negative pi over 2 to pi over 2 of 1 plus 2 sine theta plus this, d theta. And now all of that can be integrated directly. I'm going to have to get rid of my beautiful graph here. So if I bring this up here, so we've got the 4 out front, and I'm going to start writing out the antiderivative. So antiderivative of 1 with respect to theta is just theta. 2 times the antiderivative of sine theta, which is negative cosine theta, right? Because the derivative of that would be negative sine theta. That would give me the positive sine theta. And then, so this arrow is going to have to go along with this here. I'll just draw that arrow there. Okay. So antiderivative of 1 is theta. Antiderivative of this is negative 2 sine theta plus 1/2. Antiderivative of 1, again, is theta, minus antiderivative of cosine of 2 theta is 1 over 2 sine of 2 theta. There. Okay. And then we've closed this parentheses. Now we need to close the bracket here on our antiderivative. And this is evaluated from negative pi over 2 to pi over 2. Okay, I still want to clean up what's in the brackets a little bit before I plug in limits of integration. So let's see, this is 4 theta minus 2 cosine theta plus 1/2 theta. I'm going to distribute the 1/2 right now. Minus 1/4 sine of 2 theta. And so we could combine the 1 whole theta and the 1/2 theta, and so that's 3/2 theta. And then rather than write this whole line again, let's just write this. So take the sum of those two, that's 3/2 theta. And then I'm going to go ahead and start plugging in limits of integration. So upper limit is pi over 2. So 3/2 times theta, which now I'm going to go ahead and substitute pi over 2, minus 2 cosine of theta. These were combined, so I don't need to write this 1/2 theta, minus 1/4 sine of 2 theta. So that's 2 times pi over 2. So that's going to be pi. Minus, now plug in negative pi over 2. So we combine these guys, it's 3/2 times negative pi over 2 minus 2 cosine of negative pi over 2, right, cosine of theta, minus 1/4, and I'm sorry, I'm going to be cluttered here, minus 1/4 sine of 2 times theta, which is negative pi over 2. Okay, let's work on evaluating. So this is 4 times 3 pi over 4 minus 2 cosine of pi over 2 is 0, minus 1/4 sine of pi is 0, minus, this will be negative 3 pi over 4 here, minus 2 cosine of negative pi over 2 is 0, and here the 2's cancel. Sine of negative pi is also 0, so 1/4 times 0. Lots of zeros here. Okay, so this is 4 times, so what's not 0? We've got 3 pi over 4 in front, 0, 0, plus 3 pi over 4 when you distribute this negative. and then all zeros. Okay, so this 4 is kind of convenient. Distribute the 4, and you'll have 3 pi plus 3 pi. So final answer here, 6 pi square units of total area inside that cardioid graph that I had graphed originally.